Goodbye. Good morning, students.
Are you able to hear my voice? Today, I would like to discuss the topic on Module 5, that is Basic Processing Unit. Basic Processing Unit. Already, you are all aware about the basic functional units of a computer system. Already, I have discussed the basic functional units of computer systems in earlier classes. It is categorizing into majorly three parts. That is CPU is called as Central Processing Unit. Second one is Input and Output Unit. And third one is Memory Unit. These three parts are we called as the functional units of computer system. In this, the major one is the Central Processing Unit. Central Processing Unit. That is coming under Module 5 in our subject. That is named as Basic Processing Unit. Here, I would like to discuss about some fundamental concepts. My question is, what is process? What is process? Is anyone? Is anyone? Okay. Process means a program is in execution. A program is in execution is called as process. So, what computer can do or what processor can do? What processor can do? The processor can do processing. Processor can do processing. That means program executing. That means program executing. So, another question is, what is program? What is program? A program means a collection of instructions, or a program means set of instructions. A program means collection of instructions, or a program means set of instructions. Now, these instructions can execute one by one when we are submitting to processor. When we are submitting to processor, these instructions can execute one by one. So, if these instructions wants to execute, the processor has to perform three steps. The processor has to perform three steps. That means if your program wants to execute, the processor has to perform three steps. What are the three steps? What are the three steps? That is, the first step is given as fetching. The first step is given as fetching. That is, fetch contents of memory location. Fetch the contents of memory location pointed to by PC. Pointed to by PC. That means PC stands for program counter. See, PC stands for program counter. Okay. PC stands for program counter. Now, what is program counter? What is program counter? Here, the program counter means it is a register. Program counter means it is a register in a computer processor. So what is program counter? The program counter is also a register in a computer processor that keeps tracks of the memory address of the next instruction to be executed. Next instruction to be executed. That is called as program counter. That means the program counter is a register in a computer that keeps tracks of the memory address of the next instruction to be executed. So the program counter is points to the address of next instruction. Address of next instruction. So here the first point is to be focusing on the fetch contents of memory location. It's pointed by PC. That is, contents of this location is an instruction. Contents of this location is an instruction to be executed. To be executed. Once the PC is pointed to the address of next instruction, that is loaded into the IR. That is loaded into the IR. So what is IR mean? What is IR means? IR is a instruction register. IR is the instruction register. So what is instruction register? It holds the current instruction being executed. It holds the current instruction being executed. So once the instruction is loaded into the IR, that is ready to execute. That is ready to execute. Symbolically, this operation is to be written as IR takes PC. Once instruction is loaded into the IR, then the program counter value is incremented by 1 or incremented by 2, incremented by 3, whatever it may be. But here, the program counter value is incremented by 4. So, the first two steps are referred to as fetch space. The first two steps are referred to as fetch phase. So, if you want to executing an instruction, it involves in two phases. One is fetch phase and second one is execution phase. Next, what are the operations specified by instructions? What are the operations specified by instructions? It can be carried out by performing one or more following actions. That means when the instruction is to be executed, when the instruction is to be executed, it performs the following operation. It performs the following operations. Now, these operations can perform some actions. These operations can perform some actions. That is given as first one is read content of given memory location. First one is read the content of given memory location and load them into a register. That is the first operation. The first operation performing is reading. So here the register is also a memory location. It loads the content of given memory location, but actually that memory location is pointed by the PC earlier. Next, second operation is given as read data from one or more registers. For example, you take R1 register, R2 register. R1 register stores contents of first memory location. R2 register stores the contents of second memory location. Now, R1 register and R2 register is having contents. That is in step 1. Coming to step 2, read data from one or more registers. So, read data from R1 register, read data from R2 register. After completion of read contents from two registers, what operation we want to perform here? Arithmetic or logic operations. That means these operations are performed by ALU. These operations are performed by ALU. ALU stands for arithmetic or logical unit. It is also internal component of processor. Okay. Once operation is performed, either addition, subtraction, multiplication, division is coming under arithmetical. Coming to logical point of view, logical and, logical or, logical not, NAND, NOR, exclusive or, whatever it may be, any logical operation is performed. After completion of that operation, result is to be generated. That generated result is stored into a register. Finally, once result is stored into a register, finally, we can store the data from register to a given memory location. We can store the data from a register into a given memory location. That is the complete execution of the program. The complete execution of the program. You can take any program, it having three parts. One is read, second one is perform operation, third one is write. First one is read, second one is perform operation, desired operation. Third one is write. Same we performed here. Read means actually data is available in the computer memory locations. Actually, the data is available in the computer memory location. From this, you get the data first. From this, you get the data. Once you get the data from the given memory locations, then you perform operations. Here, operation is either arithmetical operations or logical operations. After completion of operation, it generates the result. That result is stored in again resultant variable, what we called as here register. Once data is stored into the register, we can perform write operation. Write operation means again the data is or result is stored from register to given memory location. Okay. Now we can look at what are the main hardware components of a processor. What are the main hardware components of a processor? Now here various hardware components are given here. One is register file, collection of registers. Collection of registers are called as register file. Collection of registers means you can take R0 register, R1 register, R2 register, dash dash or n-1 register. Control circuitry. Control circuitry is the control unit. Arithmetic logic unit. Instruction register. Next, PC. PC stands for program counter. Instruction address generator. Next, processor memory interface. Processor memory interface. In fourth module, we are having memory management. memory organization. In this memory organization, we have the processor memory interface. It is also a component. With the help of processor memory interface, we have to get the data from memory and we have to submit the data to memory. That means read as well as write, both are performed. Up to here, any doubts regarding different components of a processor and what are the phases are involved in? What are the phases are involved in execution of a instruction? So what is processor? Any doubts here? Okay. If no doubts, we will move to another topic. Bus is very important. Bus plays a very important role in computer system. Bus plays a very important role in the computer system. What is bus? Here bus means we can say that it is a system bus. Bus means it is a communication pathway. It is a communication pathway that allows different components of a computer system. It allows different components of a computer system to exchange data. To exchange data. Okay. That is called as a bus. So what is bus means? Here bus means it is a system bus. One minute. So what is bus? The bus is a okay. Bus is a system bus. It contains number of pathways. It can be used to exchange the data between different components. Now, already I discussed that the processor having a so many hardware components. You look at this screen, register files, control circuitry, arithmetic logic unit, instruction registers, program counter, processor, memory interface, like so many components are given. Now, all these components are interconnected by using wires, by using channels. Then it forms a path. That is given as all components of CPU are interconnected via a single common bus. Single common bus. Okay. Now the bus is having three types of lines. Three types of line. That is address bus, data bus, and control bus. Address bus, data bus, and control bus. Okay. Now, here you can take data and address lines of the external memory bus is connected to internal processor via MDR, stands for memory data register. MAR stands for memory address register. For example, you look at this simple single bus organization. Simple single bus organization where it's having a internal processor bus. Single bus organization, it's having internal processor bus has two sides. One side is having PC, stands for program counter. MER stands for memory address register. MDR stands for memory data register. Y is register. MUX is multiplexer. ALU is arithmetic logic unit. Z is register. Coming to another side, it's having instruction, decoder, and control logic. Instruction, decoder, and control logic. It's instruction register and register file. Register file means R0, R1, R2 dash dash, Rn minus 1. Temp is another register. Temp is another register. This is a simple single bus organization. Now coming to here, where MDR, you can observe the MAR and you can observe the MDR. When you observe the MAR, it's having input is connected to internal bus. And you can observe the MDR is having two inputs and two outputs. MDR is having two inputs and two outputs. That is, data may be loaded into MDR. Data may be loaded into MDR either from memory bus or from processor bus. Either from memory bus or from processor bus. That's the reason MDR is having two inputs as well as two outputs. Two inputs as well as two outputs. But MAR is having only one input and one output. That is MAR and MDR. You can observe clearly. So where these two are connected to memory bus. So MAR is having address lines. MDR is having data lines. MAR is having address bus connected to address bus. MDR is having data bus. These two are called as memory bus. These are called as memory bus. That is getting data from outside and submitting data to system is one way. Okay. Now, instruction decoder and control logic is another side. We are having instruction decoder and control logic unit. It is responsible for issuing control signals. It is responsible for issuing control signals to all the units inside the processors. To all the units inside the processor. Okay. That is the responsibility of instruction decoder and control logic unit. So, the instruction decoder and control logic unit responsibility is it is issuing a control signals to all the units inside the processor. Implementing the actions specified. Implementing the actions specified. Only processor. Here, processor can access three registers. You can observe in this organization, it's having totally three registers. The processor can access three registers. One is Y register. Second is Z register. Third one is temporary register. These two are used during the program execution. These three registers are used during the program execution. Now, you can take arithmetic or logic unit. Arithmetic or logic unit, where it performs arithmetical or logical operations. Now, it takes two inputs. It takes two inputs. One input is A, another input is B, where A input is get from the output of the multiplexer. A input gets from output of the multiplexer. You can observe multiplexer is named as MUX. You can observe multiplexer is named as MUX is having two inputs. One input is named as constant 4. Another input is named as Y. It has to select, the multiplexer has to select either 4 or Y. It produces one output. It produces one output, where output is maybe 4 or output may be Y. That output has given to A input of ALU. That output has given to A input of ALU. So ALU is having one input A is the output of multiplexer, where multiplexer has to select either 4 or Y value. That is the one point. Second point is B. Second point is B. B is another input. B is another input which is taken from internal processor bus. It is taken from internal processor bus. Okay. Once ALU received the value A and the value B, then it performs operation, either addition, subtraction, multiplication, division, or logical operations. Whatever it may be, it performs. Finally, that output is stored into Z register. That output is stored into Z register, where Z is a output register. Z is a output register. Now, an instruction is executed by performing one or more of the following operations. An instruction is executed by performing one or more of the following operations. So what are the operations it's followed means? The first operation is given as transfer a word of data. Transfer a word of data from one register to another register or to the ALU. So what is the first operation is transfer a word of data from one register to another register or to the ALU. Once the data is transferred to the ALU, where ALU can perform arithmetic or logic operations. ALU can perform arithmetic or logic operations, and finally, it stores the result in a register. And finally, it stores the result in a register. Once the result is stored in a register, go to third line. Third line is fetch the contents of given memory location. Fetch the contents of given memory location and load them into a register. And load them into a register. Finally, we can store a word of data. We can store a word of data from a register into a given memory location. Store a word of data from a register into a given memory location. That is, the operations is performed when an instruction is executed. That is the single bus organization. Now, what is the disadvantages of the single bus organization? Here is it's only one data word can be transferred over the bus in a clock cycle. Only one data word because it's having single bus. Single bus means it transferred only one. It's transferred only one word of data. One word of data at a time is one point. Second one is limited address spaces. It's having limited address spaces. Next. Third one is it may require additional circuitry for decoding addresses. It may require for decoding addresses. These are the some disadvantages of single bus organization. What are the advantages? Means it's efficient. It's efficient. Why it is efficient means here there is no overhead, there is no additional overheads can be involved when the data is transferring. That's the reason it's efficient. That is about the single bus organization. Okay, so how to overcome this disadvantage of single bus organization means we have to provide multiple internal paths. We have to provide the multiple internal paths or multiple internal paths. That means the multiple path allows several data transfers to take place in parallel. To take place in parallel. That is called as multiple bus organization. It's called as the multiple bus organization. So here given as the disadvantage of the single bus organization is only one data word can be transferred on ఇక్కడ. Only one data word can be transferred on. But how to overcome this problem means we have to provide the multiple internal paths. We have to provide the multiple internal paths. So multiple internal paths means we have to use multiple internal processor buses. Multiple internal processor bus that we have to take. So multiple internal processor bus means it's having more buses. It's having more buses means it's transferred more number of data words at a time. That is the solution of the above problem. Okay, students. So tomorrow class we will discuss about register transfers. It is also very important. So in this case, here also we can use the single bus architecture. With the help of single bus architecture, how we can transfers the data. Transfers means how data is moves in between registers. That is we can discuss in the tomorrow class. Okay, students, bye. Thank you very much.